In this example, we're going to find the scalar projection, the vector projection, and the orthogonal projection of U onto D. Now, just to recall, if we look at a vector U and a vector D, the vector projection of U onto D is this vector right here. So that guy. That's the vector projection of U onto D. Its size is the scalar projection. And if we look at the formula for the projection of U onto D, we get U dot D over length of D times D over length of D. This is a unit vector, which means this is the length of that projection. So that's the scalar projection, or the component. The orthogonal projection is the piece of U that's not in the projection. So in fact, it's this length here. Okay. And so that's U minus the projection. Okay, so let's first start with the scalar projection. So the component of U onto D is U dot D over length of D. So in this case, U dot D is 2 plus 6 is 8 plus 3 is 11. And the length of D is 9 plus 1 is 10 plus 4 is root 14. So that's the length of the projection, or it's also called the component, or it's called the scalar projection. The projection of U onto D is this number here, the U dot D over length of D times D over length of D. Now remember that while the numerator here is a single number because of the dot product, this D here is a vector. So we've got our 11 over root 14. This is also a root 14. So times 1 over root 14. And D in the question is 1, negative 2, and 3. So that makes the projection equal to root 14 times root 14 is 14. So we've got 11 over 14, negative 22 over 14, and 33 over 14. So that's our projection of U onto D. The orthogonal projection is everything from U that's not in the projection. So it's U minus the projection of U onto D. So, of course, U is 2, -3, and 1. And the projection is that 11/14, -22/14, and 33/14. And if we do out that arithmetic, 2 is 28. 28 minus 11 is 17/14. 3 is 42, so -42 plus 22 is 20, -20/14. And 1 is 14 minus 33 gives us a -19/40. -19/14, I should say. And so that's our orthogonal projection. Now you can go ahead and verify that, in fact, the projection and the orthogonal projection, those are, in fact, orthogonal, right? They're at 90-degree angles. Okay, you can do that by taking a dot product. But you'll find that they are, in fact, one is, in fact, in the direction of D, this guy here, and one is perpendicular to that.